My name is Bate Aksam, and today I'm presenting a project called GridGuard, an AI-powered transformer theft prevention using Telecom network intelligence. This is what we're going to look at. Of course, the introduction, why this project, the problem statement, what we're trying to solve, and how our solution solves the said problem or the stated problem, how it works, and then what is the business model that this application has. So in 2025, Uganda faced a wave of organized terrorism as 17 suspects were charged with systematically vandalizing the nation's electricity grid. So these people went ahead and sabotaged high voltage power lines, electricity poles in areas of Kampala. Kampala is the capital city of Uganda, up to Mubende, including critical infrastructure like military hospitals and other important places, provoking economic chaos. So the president of Uganda, Yoweri Kaguta Museveni, so he responded with an interagency security committee and a controversial shoot to kill threat against what he called economic terrorism. So these people were aligned into court and were charged for terrorism, and this sabotage costs up to 50,000 per incident to replace a transformer, causing long power outages and then distorting economic processes, people who depend on electricity, and the measures which are existing right now, like CCTV and other smart sensors, have consistently failed. Hence, the upsurge into the chaos or the vandalism of the transformers. So what is the problem in this case? So we are saying that organized theft and vandalism of electrical grid infrastructure across sub-Saharan Africa causes severe cascading impacts. This sabotages and triggers economic chaos, diverts funds from electrification to costly repairs and destabilization of the critical military and industrial sites of a country. So each site costs up to $50,000 for transformer replacement, and millions in operational losses from cable theft, forcing capital reallocation. This means that money which would have been used for electricity, for supplying electricity to new areas, it is spent on fixing stolen or vandalized power infrastructure. So this disrupts, this has a cascading effect from the top, whereby the government can't provide services to its people, but also to the small livelihoods which depend on power, people operating small shops, people operating electricity, critical businesses, saloons, and all these core environment or local businesses, which cripples the economy at large. So what do we propose the solution is? So we're proposing that GridGuard is we are repurposing the Camera APIs, that is SIM swap, device status, location verification, and then quality of service on demand for low-cost infrastructure, for low-cost transformer theft protection across sub-Saharan Africa. So we use AI so that we analyze real-time network events and also identify threat patterns, and then we identify threat patterns and then predict risk zones and trigger preventive measures automatically. So we have 4 cores that we focus on. The first is detection. We use the APIs to detect when there is an action happening. Then we analyze that data using extra APIs, as we're going to see, extra APIs to make sure that we capture as much information from the triggers, and then we analyze it with AI to make sure that we define a pattern, we go through historical data if there is any, and then we escalate it to the relevant parties, and then lastly we do manual resolution, or the system tracks resolution into the app. So how does it work? Now we're looking at installing IoT devices which have SIM cards, and using the Nokia APIs, network as code APIs. So we register the devices. That means we capture their real-time location, and then we set a boundary of 50 meters. So this means that we set a perimeter that a transformer or an asset cannot go beyond 50 meters. And then we do device verification to make sure that the device is still in the registered location. If there is any difference between the current location and the radius or the perimeter that we drew up on this transformer, then we trigger an event. So GridGuard does a continuous assessment of the asset from registration to monitoring its real-time location promptly, so that we keep this in check. Then once we get a trigger, then we can analyze this data with AI. So right now we're using Gemini. So it analyzes the triggers that we have received and then the previous behavior of this specific device, and if it needs manual intervention, then it raises an SMS alert to the relevant people. Then they can respond, and then after they can tell us what security actions or what measures they took when this alert arose. Then what is the business impact of our proposal? So we are saying that GridGuard can be priced per device. So we are saying that we're providing infrastructure protection using the Camara APIs for device protection. So that means we can have it is designed as a SaaS. So it means that we build one and then it can fit multiple use cases. Then we can charge per user per device. So that means that we propose $30 per device per month, so that we give them continuous support and protection. Then we can decrease the price depending on the volume of the person or the user is having. Next, the other model we're looking at is a bundled subscription. For example, we could say $30 per device per month, but then we say that if someone goes, let's say if someone has let's say the month is in the middle, you've just enrolled, then we can prolate and then charge you for only what you use. And then we can also encourage people to subscribe for longer periods, and then we give them a discount. Then lastly, we're looking at an enterprise where we can have a base fee, and then we can have unlimited support for this specific client. So we're looking at 50,000 per year, and this is inclusive of any devices. So we don't have a cap on the devices that you can monitor. Then lastly, we have now the product gallery, and I think I'll go through the product demo, then come back to the other sectors that we think that GridGuard can be useful. So I'll go to the demo. So click here. So this is our platform. We give information to people what GridGuard does, how does it do escalation, what APIs do we use, how do we use SIM swap detection, and then how do we do the resolution. Then we have our features that we provide, and then we have the pricing. So we've set pricing at 30. Then we have this this monthly 1,000, then billed annually at 12,000. So this is up for we try to experiment with multiple pricing tiers to make sure that we cover more ground. So launch console. So here, so this we sign in with Google. So I have already signed in. So what happens is an asset, when someone wants to track their device. So we say I want to track this device. This device is called let me say Kawempe transformer 01. Then what is the serial code? Then what is the phone number? So we're using this we're using the APIs. So I'll do my serial number as these are the numbers provided by Nokia Networkers code. So I'll do this is my let me see. Okay, I'll do this. Then the destination number, this is the number which is supposed to receive the alerts in case the perimeters are breached. So I'll do 780-74-2043. Then I'll verify So if I have a valid number, then we prorate and tell you, we distribute the per device amount with what is remaining for that month, so that the next month you build the initial fee of the base price per device. So I'll confirm and pay. So what happens, we create a perimeter around that transformer. So we say that where you register the device, we put a perimeter wall, and once it is breached, so if we call the API and then we cannot verify that location, so it raises an alert for you. So what are the APIs that we use? Among the APIs we use, we include the get device location. That's the first we use, and then we also use it for verification, such that when we get the right coordinates, we know that that's the right device. Next, we use the geofencing. So we make sure that we draw a perimeter of 50 meters around the registered location. Then thirdly, we now start polling the device location. So one of the incidents that I raised earlier, so let me just reactivate this, some of the transformers that I had on this system. So I'll reactivate this. So what we do, every 5 minutes we keep polling what happens from the location of the transformer. So we poll the transformer, and then once we get a discrepancy in the transformer location, that's when we can now call the SIM swap endpoint to make sure that if the location has changed, was the SIM swapped, was the device swapped. So if any is true, if the device was swapped and the SIM was swapped, it means that this person, or this is an organized theft. This is a cartel, unlike a random theft where someone can just randomly maybe steal the transformer. It means this person has prior knowledge of what has happened and what has happened and how the system works. So once there is that drift, so we start getting warnings. The system warns us, and then it gives us an AI analysis. So for example, this transformer here, you can see that it's in red, and then we have an AI analysis that the transformer is in a critical threat state while the GPS coordinates align with the registration. The combination of the rest is the recent swap sweep. So this for this specific transformer, it is at the same location where it was registered, but there is a SIM swap. So this means that either the SIM or the device was tampered with. So this means that it is an organized crime. Then it sends a notification to the person responsible. So when you look at this one shows that signifying a limited operation failure. The most concerning factor is this SIM swap, and strong indicator of so this is an AI analysis to show us what has happened or what AI thinks has happened. So for this specific SIM, it was swapped, and also the location doesn't match, because we did a location verification and it doesn't match. So once a prompt is received, so on the phone, so this person can be able to mark as resolved to show us what measures that they took to solve this specific problem. Now, we can build further analysis, capture images, capture a report-like setup for what has happened, but this gives us the idea of how the system handles the situation up to resolution. Then this one for the same, we'll mark it as resolved, and once it is resolved, we can now go ahead and reinitiate it. So we can reinitiate it to make sure that the other issue was resolved, but then it needs to be reinitiated. So this is the one, so I'll mark this as resolved, so it goes back to draft. So that's how our system works, and that's how we expect to curb transformer theft, by notifying the relevant parties in real time, and then also making sure that we track the steps which are taken in order to sort out that specific vice. Then what other sectors we think our platform